All right, hello Algebra 2 people. Here we are again. Today we're looking at section 1.4, rewrite formulas and equations. And you'll also hear this section referred to as literal equations. Let's get a definition down to start things out. The definition we're looking at is the definition of a formula. A formula is an equation that relates two or more quantities. It's an equation that relates two or more quantities, usually represented by variables. And I'm sure you can think of quite a few formulas, and there are a lot of formulas that are very straightforward, I guess we could say. Distance equals rate times time. There's a lot of geometry formulas that you learned last year. Area equals length times width, or area equals base times height, depending on how you want to look at it. Area of a triangle, area is equal to 1/2 base times height. Area of a rhombus is like area equals 1/2 diagonal 1 times diagonal 2. Different things like that. You've got a lot of experience with formulas. And even though you've had a lot of experience with it, this section can be particularly tricky for a lot of people. So let's dive in and see how we feel about it. Let's see here. Let's begin with some examples. Our instructions are to solve the equation for y. Solve the equation for y, and then it says to then substitute the given value into the equation. Now, sometimes class, you'll only be expected to solve the equation for y, or solve it for x, or whatever it may be. And you may not have this second component where you actually substitute in a given value or evaluate the equation. But we're going to do them in this order. If you could actually, at the very beginning, substitute the given value for x and then solve for y. But we're going to do it in this order because sometimes you're only expected to do one thing at a time. And our equation is 2xy minus 3x equals 6. 2xy minus 3x equals 6. And we're supposed to solve the equation for y. So let's do that part first. Now what people find, this is not a formula, it's an algebraic equation here, but you work them the same way. Whatever variable they say you want to solve for, I like to put a dot on it, and we're going to solve for y. We're going to get y by itself. We're going to isolate y. And to be honest, there's a lot of possibilities here that we could do. To get y by itself, I'm going to have to get rid of this 2x part. But what's curious about that is this 2 and this x and this y, they're all multiplying. So I would have to divide 2 and divide x. And when I do that, division and multiplication, they distribute across addition and subtraction. So if I were to do that first, I would have to divide by 2x here, divide by 2x here, divide by 2x here, which might be a little bit messy. Not too bad, but customarily what people like to do is they like to undo the addition and subtraction first. So I'll start out with that. I'm going to move that 3x over. 2xy equals. And those are not like terms, okay? I got to keep them separated. I can either write 6 plus 3x or 3x plus 6. It seems like it's more customary to put the variable expression part first, so I'll do 3x plus 6. But it would be okay the other way as well. From there, I'm still trying to keep in mind that I've got to get y by itself. And now, I'm going to do that, well, like I was saying, I'm going to divide everything, but division distributes. So I'm going to write divided by 2x, but then when I divide this other side, it distributes across addition. So I'm going to divide by 2x, divide by 2x. And it's kind of curious what ends up here. The 3x divided by 2x, the x's will divide out, and we'll be left with 3 halves. Avoid the decimal. You don't want that. 3 halves is simplified, and everybody knows it's an exact answer. If we put a decimal in, people might think we're starting to round things. So we get 3 halves, and then plus, and over here we get 6 divided by 2, which is 3, but our x is stuck in the denominator, like so. So at this point, we have solved for y. We've gotten y by itself, but we had an x still left in our equation. From here, I'll go ahead and let you in on a secret that we are given that x is equal to 3. So it says, then substitute the given value in the equation. So our given value is that x is equal to 3. We're now going to substitute that in and finish the rest of the problem. So we're evaluating this equation when x is equal to 3. Substitute 3 in for x. I can simplify this. 3 halves plus 1. There's a couple ways you can proceed. Your calculator can certainly do this for you if you punch that in. But one way to think of it is 3 halves is 1 1/2, and if you add 1 more, you have 2 1/2. That would be one way to get the answer. Another way to do it is 1 is actually equivalent to 2 over 2. Now, why would I rewrite it as 2 over 2? Because now I've got a common denominator. And so when you have a common denominator and you're adding, you add your numerator. So the answer is 5 halves, or you could also write 2 1/2, however you want to do it. Please avoid writing the decimals. We want fraction answers. Mixed numbers or improper fractions, either one is a-okay. All right, let's do another one involving x and y. Same instructions, okay? Same instructions. And we've got y times 4 minus 2x equals 12. And I'll go ahead and tell you what we're going to be given. We're going to be given that x is equal to -4. But we want to solve the equation for y first. Okay, solve it for y first. So, trying to get y by itself, you might be tempted to distribute the y. But in a sense, that's going to complicate things. Because when I distribute that y, I'm going to have 4y minus 2xy. I'm then going to have to solve for y, and I'm going to have 2 of them to deal with. So let's avoid that. Let's hold our horses here. Don't distribute. Instead, think about this. I'm trying to get this y by itself. That y is multiplying with this parentheses. How can I undo multiplication? By division. I'm going to divide by 4 minus 2x. That will undo it, and all of a sudden I'll have y by itself. Now I got to keep my equation balanced, so I'm going to divide by 4 minus 2x. So kind of the strange thing about doing formulas, rewriting formulas and equations is a lot of times your result is not any simpler looking than what you began with, but it's written a different way. And that's kind of the case here. Those divide out to make 1, and we get y equals 12 over 4 minus 2x. Now class, you could actually simplify this some more. I'm not really concerned about that right now, that you do that, but I do want to show you that you could take this further. Do you see how 12, 4, and 2, they're all divisible by 2? When that situation happens, you can simplify the fraction. The long story is that you write 12 over, you factor a 2 out, leaving behind 2 minus x. And then from there, because it's multiplying, you can divide the 12 and the 2, and you get y equals 6 over 2 minus x. I'm not too concerned about this last step right now, but eventually, later on in the year, it's going to be a mandatory last step. The focus on this is getting the variable by itself that they ask you to solve for. So that's the real focus. But so this is good. For right now, you'll be just fine. But to go that extra mile, to understand that a 2 will divide out from both the numerator and the denominator. That's a pretty valuable skill for later on. Okay, so we're still not quite done. We need to substitute the given value in the equation. So I'll just take this one right here. And all right, y equals 12 over 4 minus 2 times negative 4. Like so. Put parentheses around it. It makes a little more sense. You know that you're multiplying. We're going to do order of operations here. Going to do the multiplication first inside. Now, a fraction can act as a grouping symbol, so this denominator is kind of grouped together. So within there, we're going to do order of operations. We're going to get 4 plus 8. Now, before I divide this or simplify this fraction, I need to add the 4 and the 8. So we get 12, and 12 divided by 12 is 1. And there we go. So we solved for y, and then we substituted in the given value, and we got y is equal to 1. Okay, so let's move on to a couple of formula examples and see how you feel about it. It's the same sort of thing. It's just that with the different variables and the addition of more variables, people can get a little bit turned around with this. All right. Our instructions are solve the formula. Solve the formula for the indicated variable. And our next example gives us, oh my goodness, okay, so I already mentioned this one. This is this formula is for the area of a rhombus. 1/2 diameter 1, diagonal 1 times diagonal 2. Now keep in mind, when there's nothing written in between, that's implying multiplication. And we're asked to solve for D1. Solve for D1, diagonal 1. Well, again, I would would suggest, since we're asking us to solve for diagonal 1, to put like a dot above diagonal 1 there. And we got to think about undoing everything that's going on this side so that we can isolate or solve for D1. So I need to undo multiplication. Now, whenever I have a fraction, I don't like to divide by fractions. I never do it. I realize that dividing by anything is the same thing as multiplying by its reciprocal. So I'm actually going to take care of that 1/2 by simply timesing by 2/1 or 2. And I'm going to do that right away. And get 2a is equal to, the 2's divide out, make 1. And I get D1, D2. Still trying to get D1 by itself. I hope you guys are okay with that. Yeah, if you in your calculator you do, well, you can't use your calculator because it's variables, but you can divide by fractions in your calculator, but I think it makes more sense, and I hope you get used to the idea of multiplying by the reciprocal instead. All right, so to get D1 by itself, we now divide by D2. Nothing simplifies, but we have D1 solved for. And typically we like to write it on the left-hand side. So diagonal 1 is equal to 2 times A divided by diagonal 2. Looks kind of funny, but it's the same steps that we used in these types of problems. We just undid what was being done to the variable to get it by itself, excuse me. All right, let's try another one. This is the volume formula of a right circular cone. You probably saw this towards the end of geometry last year. If you got to this point, got to volume, I hope you did. Volume's all around us. So we're going to solve this formula. So we got pi. Pi is not a variable, is it? It's a number. It's an irrational number. It can't be written as a fraction, but it's a number. But we've got radius and height that we're dealing with. And they want us to solve for height. Solve for h. Solve for height. And again, I'm going to use the same technique of putting the dot over what I need to solve for. I need to get that h by itself. That h is multiplying with the r squared, and it's also got this pi over here. And also it's ultimately being divided by 3. Now here's what's tricky about this. Here's what's tricky about this. Actually, I guess it's not too bad. I like to think of fractions as grouping symbols. So what I kind of want to do is I think of these as kind of being one thing and the 3 being separate. So my first step on this would be to multiply by 3 to undo dividing by 3. And I end up with 3b equals, that divides out and makes 1, pi r squared h. I like doing this problem that way. Technically because, well, let me think about this. Yeah, I mean, you could do things other ways. You could, if you wanted to, divide by r squared and pi first. Maybe they cancel out and then divide that. That would work as well in this case, but I like the idea of getting rid of the 3 first. From here, we need to get h by itself, and I'm going to do this in one step. You could split it up into 2 steps, divide by pi first, then divide by r squared on both sides, but let's do it all at once. Pi r squared, pi r squared. And at this point, those divide out to make 1, and we've got our answer. I'll go ahead and write the h on the left-hand side. Height is equal to 3 times the volume divided by pi r squared. And we have solved for h. So do you see how this can be kind of tricky, kind of different? Your answers aren't necessarily pretty, so that kind of bothers people. But take your time and think about the steps to isolate your variable. Inverse operations, undo them. All right, looks like I've got one more to do. One more to look at. And here's the thing, are there countless numbers of formulas out there for different things? Oh my gosh, yes. So, I can't cover every possibility, but think about that idea of inverse operations to undo things. So let's look at, this is a perimeter formula. So it's the same instructions, we're going to solve for something, but it's a perimeter formula. Perimeter is equal to 2 times the base plus 2 times the side, which is kind of funny way to do it, but they say 2s. So 2 times the base length plus 2 times the side length. And we want to find, we want to solve for b. Solve for b. Okay, so put a dot with b. I'm going to get it by itself. You got some options here. You could. All right, sorry, I had technical difficulties. Whenever you're recording a video on your phone, make sure to turn it to airplane mode. That way when you get a call, it won't stop the video. That's what happened to me, so I'm having to start over. I apologize. Where I left off was put a dot above the b, and then we're going to solve for b. We're going to get b by itself. You could do this 2 different ways. You could decide to undo the multiplication here, but you would have to remember to distribute it. Or you might prefer to undo the addition, and a lot of people prefer to do that first, so that's where I'll take us. So we'll subtract a 2s to undo that. Keep your equation balanced by subtracting a 2s there. These are not like terms, so we get to just write them on the same line there. And now it's clear I got to undo this 2 to get b by itself. But again, I'm going to distribute across addition and subtraction. And I get, I'll go ahead and write it with b out front. B will be out front, solved for. And we'll have p over 2, nothing I can do with that. But then I can divide these 2's out to make just an s, which is kind of cool. And we solve for b. Now, in actuality, let me get my marker here. In actuality, you also are told, forget my notes here. You're also told you're going to solve for b when p is equal to 26 inches and s is equal to 4 inches. So now we're going to do that next step where we get to evaluate the formula for a given value of s and p. So we're just going to simply substitute in for p a 26. I'll keep the units in there. And in for s a 4. And I'll keep the units as well. And from there we're going to simplify it, which would get us 13 inches minus 4 inches to make 9 inches for b, or our base. And there you have it. So again, it's impossible for me to cover every single formula out there, so you got to really respond to what the problem contains. Remember inverse operations. Undo things so that you can get your dotted variable by itself. The homework for this is, or the practice I should say, is page 30, numbers 3 through 10, 18 through 23, and 35. I know it's new in the year, but on these book assignments, I typically suggest that you start off doing the odds first. If you get the odds all done in class, then you can move on to the evens. But these assignments usually have more problems than I feel are necessary, to be quite honest. If you do the odds and you feel and you get it done in class, then you should be in good shape. If you're working the odds and you don't get done in class, you're running a little bit of risk of not being fully prepared. So do the odds first. Do the odds first. Ideally, I don't want you doing problems outside of class. All right. Hey, thanks for watching. Appreciate it.